Now that we've looked at some basics of vectors, let's look at some operations that we can do with vectors. The first one is addition. We are allowed to add vectors together, and so I want to give you the opening definition, but then also describe what that means. If we have a vector u, which is made up of two numbers, one x, the other y, and then vector v, which is also an x and a y value, to add them together, simply take their x values, find the sum, take the y values, and find the sum. So nothing too complicated there. Let's just try to show you what the math would look like. If I want to use the vector 3, 4 and 1, -2 to find what u plus v would equal, I simply take the x values, so 3 plus a 1, and then take the y values, so 4 plus a -2, or just 4 minus 2 in the end, and I want to put those two pieces together. So when I add them, I'm going to have for x 4 and for y a +2. So let's see why that works. Go to Sketchpad here a second, clear this off. There we go. Okay, so here are two vectors. This is 3, 4, and this is 1, -2. To visualize addition, simply take your first vector, and at the end I want you to think of this having that arrow there. Just the way that I happen to make this file, I can't get the arrow to show up there, but the arrow would be right here. Wherever that ends, move the blue vector, in this case, there, and have it start and go, basically just take this and drag it over there, make it appear. This is going to be where we end. And you can see we do end up at 4, 2. But the interesting thing about addition is if I were to say, well, I want b to be the first one and then apply a. So if I put vector a at the end of where vector b is, I end up at the same spot. So with addition, if we go back to our notes a second, one big thing to notice is that it doesn't matter the order. U plus v will equal v plus u. But what's going to happen with subtraction? So subtraction works the same way that addition would. It's just instead of these plus symbols here, you would have subtraction. So let's see what happens in Sketchpad if we look at that example. And we will wait for our friend here to move out of the way. Oops. Let's go to subtraction page. There we go. Okay, so same vectors now. If I were to think of addition, a plus b would get me here. A minus b just means take a, but then don't apply b this way, apply it in the opposite direction. So a minus b would get me going way up to here. So this green vector represents a minus b. Okay, it gets a little confusing there. I'm going to hide this original b there. So you can see a minus b just go in the opposite direction. If I were to go b minus a, well, b plus a gets me to here, that 4, 2 that we talked about. B minus a, the a is going to go in the opposite direction. So a is going to go way down there. So this purple segment represents b minus a. So again, let me get rid of that. So b minus a, or a minus b, you can see they're still related, but they go in opposite directions. So if you want to see the numbers for green, I'd end up with 2, 6. And with purple, I end up with -2, -6. So there's still a relationship there. It's just not as big of a rule that we can make with this. So going back to our notes, we already said that this was equal right there. That just means that this is not equal. You cannot reverse the order with subtraction and expect to get the same thing. Okay, the other thing I want to talk about in this video is scalar multiplication. So we're allowed to do addition and subtraction. We can also do a pretty simple form of multiplication here. So again, if we have a typical vector, x, y, and k is just going to be any number, if I want to go that number times the vector, basically it means take that number and multiply it by the x and y values. So if we go to our notes here, we have 3, 4, and 1, -2, the same vectors we had, and I want to find 2 times u and 3 times v. I can write a lot of stuff out here, but basically I would have a 2 times 3, 4 plus a 3 times the vector 1 comma negative 2. And basically just think of distributing that 2 and distributing the 3. If we did that, we would end up with 6 comma 8 plus, oops, missing some notation there, so the vector 6 comma 8 plus the vector 3 comma negative 6, and then I just need to add those together like we did in the previous example. So that would get me 9 comma 2, it looks like. Okay, so I think all that is fairly straightforward, but again, let's just go to Sketchpad, show you visually what that might look like, or at least what part of that might look like. So I can't put both of the vectors up there, but this is the vector 3 comma 4. Again, it is I don't have the arrow here, so you have to imagine the arrow there. But if I were to take a k value and simply multiply, so now it's double the length. You see how it doubles the length. If I were to go backwards, I make it -1, it goes in the other direction. It's going off the screen now, but that's kind of how scalar multiplication works, is it would kind of go from here, it would just double the entire vector if the scale factor was 2. I can make it, let's try to make it 1.5 here. And you can see that it's basically taking half of this and extending it by another half. So lots of interesting things we can do with multiplication as well. Let's stop the video there, and we'll pick it up in our next section here.